Hey guys, Mr. Wilson here. Today we're looking at graphing quadratics, part 1 notes. At the end of this video, you should be able to find the middle of a parabola, and you should be able to find the vertex of a parabola and determine if that is a high point or a low point. Okay, so a little bit of review from first semester start. It says graph y equals 2x squared minus 5 by creating a table of values. Okay, before graphing, we should know that this graph will have a U-shape because of the squared x. Okay, this is called a quadratic, or this is called a parabola. Sorry, the U shape is. We also know that the parabola will open up since the a value is positive. That means that the parabola has a minimum value. Okay. And when we talk about minimum, we're saying like there is a lowest point. If we look at our parabola, it will continue up forever, that U shape, right? And this bottom point would be the minimum. Okay, so when it opens up, it has a minimum. When it opens down, it has a maximum point. Okay, so now we're going to create a table of values like we said we would and graph this function, x, y. Remember, first semester for our table of values, we chose -2, -1, 0, 1, 2 as our x values, so we can see how our function looks positive, negative, and at 0. And so as we do that, function notation, we can use that. We just plug our x value into the function and do it, right? -2 squared gives us 4. Times 2 is 8. 8 minus 5 is 3. Okay, we do the same thing with our other values. Okay, that would be 1 times 2, 2 minus 5, -3. 2 times 0 squared minus 5, that's 0 minus 5, -5. And then we do the same thing here, going through. That should give us -3. 2 times 2 squared, that's 8 minus 5. It's 3. Okay, so all of our values just come from plugging in our x into the function here for x and evaluating that function. Okay, so 0, -5, 1, 2, 3, 4, 5, 1, -3, 2, 3, 1, 2, 3. All right, doing the same thing over here, -2, 3. Okay, so. And then we get this U-shaped curve that opens up like we expected it to. So we can feel pretty good about our answers. All right, and so there's our graph. So this parabola is symmetrical, meaning there is a line you can draw that cuts the parabola in half. This line is called the axis of symmetry. Okay, it's a big idea for this lesson here. Okay, so here it goes. It says graph y equals x squared plus 6x plus 5 by creating a table of values. Let's look at it. Doing the same thing. So as we start, we will plug in our values: -2, -1, 0, 1, 2. Okay, so doing the same thing that we did previously, plugging our values in, and you can use a calculator. I would actually encourage you to use a calculator rather than evaluating it 6 times separately. Okay, that way you can type it in, get your answer a little bit quicker, more quickly. There we go, that's better. Okay, -2 squared plus 6 times -2 plus 5. So that's 4 minus 12, -8 plus 5. -3. Okay, do the same thing for -1 squared plus 6 times -1 plus 5. It's 1 minus 6 is -5 plus 5 equals 0. Okay, doing the same thing here. 6 times 0 plus 5, and that gives us 5. Do that same thing here for 1 squared plus 6 times 1, 1 plus 6, 7 plus 5 is 12. And then do the same thing last time here. Nope. times 2 plus 5 equals, and that's what, 4, 16, 21. All right. So just using these values like we usually use, kind of our default numbers, we just talked about the fact that our parabola should be symmetrical, but then when we do this, we notice that, hey, these values aren't symmetrical. What happened? Okay, why is this not a U-shaped curve? And the answer to that is we didn't find the axis of symmetry of the parabola. Okay, or I guess I should say better, the middle. We didn't find the middle of the parabola. Okay, the middle of the parabola is where the parabola changes directions. Okay, the point at which this occurs, the change of directions, is called the vertex. The axis of symmetry always goes through the vertex. Okay, so we'll be looking at finding that middle in this next section. Okay, the first thing you should do when graphing quadratics is find the axis of symmetry and the coordinates for the vertex. Okay. So that's what we're doing today. We're not really getting to the whole graph today. We're making sure that we have solid our first steps, finding the middle and the vertex. Okay. The formula to find the axis of symmetry, okay, is axis of symmetry is x equals opposite b over 2a. Okay, a couple things. Recall that our general form for a quadratic is ax squared plus bx plus c. Okay, we kind of changed it a little bit here to make it y equals, right? Because we're graphing. But when you're asking, hey, what's b, where's a, they're the same things that we looked at when we were factoring quadratics in our polynomials unit. Okay. One thing to notice is that the axis of symmetry is a vertical line. Okay, so remember that we looked at that when we're graphing. We remember that x equals something was always an up and down line. If we had like y equals a number, it was a horizontal line. So that's just kind of review. You can kind of erase that from your mind right now. But x equals is a vertical line. That's why the formula starts with x equals. The a and b came from their general form for a quadratic. Just wrote that down up there. I'll rewrite that here. Okay, since the axis of symmetry goes through the vertex, when you find the axis of symmetry, you have also found the x coordinate of the vertex. Find the other coordinate, use your x value and plug it into the original function. Okay, and we'll do that in this next section. Okay, so here it says write the equation for the axis of symmetry and find the coordinates of the vertex for each quadratic. So here's how we do it. Remember our equation or our formula for axis of symmetry is going to be x equals opposite b over 2a. So as we look at our formula, our function, we can say a is 2, b is 8, and c is 11. Okay, even though we don't need all those letters, I'm just going to have them written out here just so we identify them. Be easy enough to plug into our formula. So x equals opposite b, since b is 8, opposite b is negative 8, over 2a. In this case, a is 2. So I have negative 8 over 4, which simplifies to negative 2. Okay, as we write this answer, remember our axis of symmetry is not negative 2. It is x equals negative 2. It's a vertical line. We can find our vertex by plugging into our function here. Just going to erase it here, give myself a little bit of space to do that. Okay. So since we know that x is negative 2 at our vertex, then we will plug in our 2 times negative 2 squared. plus 8 times negative 2 plus 11. Okay, so evaluating this, that gives us 4 times 2, 8, negative 16, plus 11. So we end up with positive 3. So our vertex will be at negative 2, because we already found our x value with our axis of symmetry. Then we find our y value by evaluating this here. Boom. Okay. Okay. Next problem, doing that same thing. Here, want to identify A, B, and C. You'll notice here with the second problem that the B, well, that there are only two values in our quadratic, right? So as we look, we can tell that 5 is A because it's in front of the x squared, and that negative 8 is C because there's no variable by it. Okay, so there's no B value here. And so really the B value is 0 here. Okay, so as we plug that in to our formula for axis of symmetry, x equals opposite B, which is 0 over 2a, which is 10 in this case. But 0 over anything is going to give us 0. Our axis of symmetry is at x equals 0. Okay, to find our vertex, then we plug it into our formula, our function, sorry, y equals 5 times 0 squared minus 8. 5 times 0, 0. So minus 8 is negative 8. So our vertex is at 0, comma, negative 8. Again, our axis of symmetry is always the x-coordinate of our vertex. Last problem here, trying to find our axis of symmetry and vertex. We're going to identify A, B, and C. A, B, C, 3 terms written in standard form, so it shouldn't be too much confusion here. A is 1/2, B is negative 6, C is 13. And now we're going to plug it into our formula for axis of symmetry. X equals opposite B. B is negative 6, so opposite B is positive 6 over 2a. Okay, so 2 times 1/2 is 1. So we have 6 over 1. Our axis of symmetry is x equals 6. Now, in order to find our vertex, we just plug it into our function. Y equals 1/2 times 6 squared minus 6 times 6 plus 13. Okay, so 6 squared, 36. Half of that is 18 minus 36 plus 13. So you have negative 18 plus 13, negative 5. Our vertex should be at 6, negative 5. Okay, and again, this is important because when we're looking at a quadratic, it should be a U-shaped curve. If we do not find the center of the graph while we're graphing it, then what we're going to end up with is what we saw here when we're just randomly plugging in numbers, right? We had negative 2, negative 3. We had negative 1, 0. We had 1, 12 that got all the way off the board. 1 or 2 or 0, 5. I skipped that 1, 2, 3, 4, 5. Okay, and so we end up with this thing where we're like, wait a second, what's happening? Shouldn't this be a U-shaped curve? Yes, it will be a U-shaped curve, but we have to find the center. And that is what this is doing, helping us find the axis of symmetry, the line that cuts our parabola in half, and the vertex, the point in the direct center of our parabola. All right, so let's look at some applications to this. It says a tennis player hits a ball over the net. The ball leaves his racket at 0.5 meters above the ground. The equation h equals negative 4.9 t squared plus 3.8 t plus 0.5 gives the ball's height in meters at any time, t in seconds. What direction will this parabola open? Okay, so as we look at it, first of all, we have this picture playing tennis. Okay, playing tennis, guy hits a ball. Okay, how's that ball going to look? If it gets hit, typically a ball does like this, right? Tennis ball. Okay, so that's just visualizing the situation in your mind, but looking at the equation, you're like, hey, A is negative. We should know that this parabola opens down because of that. Okay, because the A value is negative. Okay, this means that the parabola will have a maximum. Okay, and that's a point where the ball is at its highest point. Okay, if there was no floor or ground below it, the tennis ball will continue to fall forever. But there is a ground which causes it to bounce. Okay, so there's a maximum height. When will the ball be at its highest point on its path? Okay, that highest point is called the maximum. It is, in this case, the vertex. Okay, as we're looking at this situation, if we were to graph it in less of a picture, right, we would see that the highest point would be the vertex here. Okay, and as we look at our graph, we have height and time as our axes. Okay, and time is typically our independent variable. So it says, when will the ball be at its highest point? Is asking when, time, about our x. And so we can find that by finding our axis of symmetry. Okay, with the function negative 4.9t plus 3.8t plus 0.5, we can identify our A value, our B value, and our C value. Okay, with that identified, we're going to plug it in to find our axis of symmetry. X equals opposite B, negative 3.8, over 2A. Okay, and so as we do that, negative 3.8 over negative 9.8, and that gives us 0.39 seconds. Okay, as we round it, it should be like 0.387755102. Okay, which makes sense. You know, it's a real world problem, so might not be a pretty answer, but it makes sense. Okay, make sure you're doing opposite B, because if you get a negative number, that doesn't make sense. That would be saying, you know, a second or 0.4 seconds before he hits it, it reaches its highest point. Okay. Second question says, how high will the ball be in the air? Again, this is understanding what they're asking us in the graph. Our height is shown on our y-axis. They're basically asking us, what's the height when the ball's at its maximum point? And we've already done that. That's the vertex, right? We said the maximum is the name of the vertex in this case. So we can find that by just plugging it into our function. H equals negative 4.9, and our time where it reaches the highest is 0.39 seconds. Okay. Squared plus, where are we at? 3.8 times our time, 0.39, plus 0.5. Okay, so again, use your calculator, plug that in. That's what I'm going to do. Negative 4.9 times 3. Second answer. Squared plus 3.8 times second answer plus 0.5. Okay. All right. And that is 1.24 meters off the ground. Okay, and so that should be our highest height, or the height of the ball, the maximum height of the ball. There you go in that situation. All right, so there we go. We found our first step in graphing quadratics, finding the center, the axis of symmetry, and the vertex. Okay, next we'll learn out how to complete our graph with that information. All right, see ya.